For the second circuit, we have a parallel component and a series component. The parallel part is on the right, where there are two tubes, each with a single resistor, connected in parallel. And on the left, we have a single tube with a single resistor, just as before. And it is in series with the parallel circuit on the right. So here's a little derivation for the equivalent resistance for resistors in parallel that might help you remember the formula. So here I'm drawing two resistors in parallel, R1 and R2. The current going through resistor R1 is I1, and the current going through resistor R2 is I2. And there's a voltage across the resistors, V, and the total current through the circuit is I total, which equals I1 plus I2. But each resistor only sees the voltage source. It doesn't know that the other resistor is there. So we can just draw each resistor separately, which gives I1 equals V over R1, and I2 equals V over R2. As said before, I total equals I1 plus I2. And we can write I total as the voltage, V, divided by some equivalent resistor, Req. So if we write it out like this, we can see that we can easily derive the formula for equivalent resistor by substituting the expressions for I1 and I2 from the equations at the top right. We see that 1 over Req equals 1 over R1 plus 1 over R2. So as we fill the right bottle up with water, once again we're providing a pressure difference that causes water current to flow. The middle 2-liter bottle begins to fill with water. But will the water fill to a level that is higher or lower than the previous circuit? Let's see. Here we solve circuit 2. The 3 white dots represent the 2-liter bottles in our water circuit. We want to solve for V middle, which will tell us the water height of the middle 2-liter bottle compared to the full 2-liter bottle on the right, which acts as our water pressure source. We'll first reduce the parallel component of the circuit to an equivalent resistor. From before, we know that the formula for these two resistors in parallel is 1 over R equivalent equals 1 over R plus 1 over R, which equals 2 over R. That gives Req equals R over 2. Now we redraw the circuit and we replace the parallel component with the equivalent resistor we just calculated. Once we make this substitution, it's a simple circuit to solve, similar to circuit 1. Req for this circuit is R plus R over 2 equals 3/2 times R. I total equals V over Req, which equals V divided by 3/2 times R. And this gives V middle equals I total times R. And we substitute in for I total and get that equals V divided by 3/2 times R, which equals 2/3 times V. Therefore, we expect the water level of the middle 2-liter bottle to be approximately 2/3 the height of the bottle on the right. Let's see what happens. We see that the water level of the middle bottle has risen to a level that is higher than the level of circuit 1. We mark it with a P to indicate that this is the water level for the parallel circuit. And here's the third circuit we are going to look at. In this case, we place two resistors in series in the right tube. These resistors are also in series with a resistor in the left tube. So there's the resistor on the left tube, and here are the two resistors placed in series in the right tube. We're filling up the right bottle with water to create a pressure difference to cause water current to flow. How high will the water fill the middle bottle? Will it be higher or lower than circuit 1 and circuit 2? Let's see. The diagram for circuit 3 is shown, and it is similar to circuit 1. We solve for I total equals V divided by some equivalent resistor, which equals V divided by 3 times R. Remember, resistors add in series, so Req equals R plus R plus R, which equals 3R. V middle equals I total times R, and we plug in V divided by 3 times R for I total, which we just calculated. This gives that V middle should equal V divided by 3, or the height of the water in the middle 2-liter bottle should be about 1/3 the height of the bottle on the right. We see that the water level of the middle bottle has risen to a level much lower than the circuit 1 and 2. We marked the level with an S to indicate that this is the series combination circuit. We hope you enjoyed the lesson. Thanks!